All right, section, that's not right. Let's get the right section up there. 3.5, using congruent triangles. So this will kind of go with section 3.4, which was our introduction to proofs. This is like proving triangles congruent with one additional step. Okay, so just a recollection here, some ways to prove two triangles are congruent. So we have side, 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 angle, side, angle, oops, goodness. Angle, side, angle, 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 side, and for right triangles, we have the hypotenuse leg theorem. All right, so looking at these two triangles to the left, we know that they are congruent by which of those 5? Well, if we follow, we have a side, an angle in between, and another side. So we can say that by side, angle, side, triangle KLM is congruent to triangle TUV. Okay, so because we met one of these 5 shortcuts. Now, what else must be true? So we already know, for example, that MK and VT are congruent. Okay, but what else do we know that's not marked? Let's talk about that. So we also know then that, let's start with the angles. That might be the easiest. So we know that angle L must be congruent to angle U. If these two triangles are congruent, then all the parts are congruent. We kind of talked about that before. Yeah, we also know angle M and angle V are congruent. Angle M is congruent to angle V. And we know that this side here, we'll call ML, is congruent to VU. Oh, I erased this. So we said it was side, angle, side. Okay, so CPCTC, what does that stand for? Corresponding parts of congruent triangles are congruent. CPCTC. So what this really means, so if we prove the two triangles are congruent, then all of the parts that we didn't mark are also congruent. So like up here, for example, we proved that these triangles were congruent, or we could say that they're congruent by side, angle, side. Okay, because we have two sides and the angle in between. But what CPCTC tells us is that the rest of the parts are also congruent. That's how we were able to say these 3 things right here. So if the triangles are congruent, then every single part is congruent. So here's how it works in proof form. So we're really going to get into proofs this week. So we'll talk about 3.4 again, which was our introduction to proofs. So given AB is congruent to CB. So anytime you're given information in a diagram, mark it off right away. So we know that AB is congruent to CB. So anytime it's a side, we use a little dash. If it's an angle, we'll use an arc. We know that AD is congruent to DC. This is all given to us. Okay, prove that angle A is congruent to angle C. So first, you must prove the triangles are congruent, the left triangle and the right triangle in this diagram. And it says mark your diagram as you go. So your first statement in a proof is always what you're given. So AB and CB are congruent, AD and DC are congruent, and then your reasoning is that it's given, always. Okay, here's what else I can say, and this is my best advice when you're dealing with triangles that share a side. Well, I should use 2 marks here, sorry. I don't know that all 4 of those are the same, I just know that those 2 are. Anytime you have triangles sharing a side, mark that right away. The shared side BD here. Mark it right away, because it's usually forgotten about. And so we can say that BD is congruent. Whoa. To BD, And the reason that is because it's the exact same side, but technically we call that the reflexive property. Come on, there we go. Yeah, we call that the reflexive property. So anytime they share a side, mark it right away. Because of the reflexive property, we can say that those sides that they share are congruent. Now I actually, if you look at my diagram, I actually know that two triangles are congruent. So they're telling me that BAD and BCD are congruent. Why? Well, look at what we have marked. We have a side, another side, and a third side. A side, another side, and a third side. So using one of these one of these 5 shortcuts, we can say that by side, 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 these two triangles are congruent. So that would be a triangle proof. Now what CPCTC says is you can actually take that one step further. If those two triangles are congruent, then everything's congruent. So once I prove the triangle's congruent, I can say that angle A is congruent to angle C because of CPCTC. It's just a fact. Once you prove triangles are congruent, then every single part of those triangles are congruent. So we're going to get good at triangle proofs, and then we'll just take it if we're trying to prove that parts of a triangle are congruent, or like the angles in this example, then we have to use CPCTC. We got one more example. Quick set of notes this week. So given AB, these two vertical lines mean that they're parallel. So AB is parallel to DC. So I'll go ahead and mark that with an arrow. That's what arrows mean, parallel lines. Anytime you're dealing with parallel lines, you're probably going to have to come back to like alternate interior angles, alternate exterior, and stuff like that. And CA is parallel. So now I got to use 2 arrows because I already used 1 arrow for the other sides. So CA is parallel to BD. Okay. It says mark your diagram as you go. I'm gonna go right here, right away. I see that these two triangles share a side. AD. So my first thing, state what I'm given. My reasoning is that it was given. Second thing, I'm gonna say AD is congruent to AD. They share that side. I'm gonna mark it. I marked it right away, actually already, because of the reflexive property. Always. Okay. Actually, I'm gonna mark what I'm adding in a different color. So there we go. I added that. Now we have 2 sets of parallel lines. So here's what I can say. So follow me here. We can say that angle CAD. So this angle right in here is congruent to BDA, that angle right there. So we'll go angle CAD is congruent to angle BDA. The reasoning is we have parallel lines. Anytime you have parallel lines, we can say something about either alternate interior, alternate exterior. Usually, in this case, we have alternate interior angles are congruent. Okay, so I'm going to erase my markings there and remark them. So I said that this angle down here and this angle here are congruent because of their alternate interior. If you turn your iPad or whatever you're using to watch this, you can see we have parallel lines going the other way. I'm actually going to turn mine as well to help me see. But now I can say that this angle here and this angle up here are congruent because we have parallel lines and they are alternate interior angles that are congruent with parallel lines. That's always true. Now I need to name these, so let's go angle CDA that way, and BAD because they're alternate interior angles. Like I said, if you turn your iPad, you can maybe see that a little better, but they are alternate interior angles. So now the next step, it's kind of nice. They told me that triangle ABD is congruent to triangle DCA. So you got to look at what information do I have. Well, let's see. We have an angle with one arc, a side in between, and an angle with two arcs on the top right triangle. I have an angle with one arc, the side in between, and an angle with two arcs. So I can say that these are congruent by angle, side, angle, which is one of these 5 shortcuts to prove triangles are congruent. So that would be a triangle proof. The last part using CPCTC, which you can probably guess is the last part. We can say that AB is congruent to CD. These sides are congruent because the triangles are congruent. You can pick any sides that line up. They should be congruent. Any angles that line up, they should also be congruent. So there you go. More proofs.